In this slide presentation, we will review Skill 1, Basic Graph Skills. The goal of this Skill 1 of Basic Graph Skills is for you to focus on identifying topics and variables that you will see in graphs. We will also focus on the x-axis, y-axis, and their scales. First, we're going to review some fundamental parts of graphs. Every single graph needs to have a title. This is very important because it tells the viewer or reader of the graph what this graph is all about. The graph also must have y-axes and x-axes labeled. Notice that the x-axis is on the bottom of the graph, it is on the horizontal line, and the y-axis is on the vertical line. We also start our graphs at 0, and we also need to make sure that whatever scale we use, and no matter what type of graph we use, that our scale is evenly spaced. When you view a new graph for the very first time, there are a series of questions that you should ask yourself to help you understand what the graph is communicating. One of these questions is, what is the topic of the graph? What is the graph comparing? What is the independent variable? What is the dependent variable? What is the scale of the data? And lastly, what is the source of the data? If we're trying to tell the topic of a graph, there are some things that we can do that will help us figure out that topic. First of all, we can look for clues for the topic of the graph on the title and on the x and y axis. If there's a key, we can look to see what the key is comparing. All of these things will help us to determine what the topic of the graph is. Let's look at this as an example. How can we tell the topic of the graph of this graph? Well, first, let's look at the title. The title says, Top Activities to Reduce Stress Among Americans with a Great Deal of Stress. Wow, that's a really long title. And I can see, if I look at this graph, that there are percentages and that there are different activities that individuals might do to reduce stress, like meditate or pray, eat healthily, and exercise. So if I was going to say what the topic of this graph is, I could say the topic of this graph is ways that Americans reduce stress. Perfect. Let's look at this next graph. How on earth can we tell the topic of this graph? First, like I said, let's look at that title. The title says possible spread of COVID-19 with and without protective measures. So on this x-axis, we see time since first case, and on the y-axis, we see number of cases. So I know that this graph is comparing protective measures and no protective measures to see the number of cases that exist. So I might say the topic of this graph is comparing protective and not protective measures and looking at the number of cases that exist of COVID-19. So now that we generally know how to find the topic of a graph or what a graph is trying to communicate to us, we now need to investigate the difference between independent and dependent variables. If you remember, an independent variable is changed on purpose by the experimenter. A dependent variable is what we observe and what we measure. And remember that the dependent variable depends on the independent variable. So let's look at some examples to help clarify this idea a little bit more. On this slide, we're going to look at some examples of independent versus dependent variables to make sure you understand the difference. I would like to first look at this plant example here. The independent variable is the thing that the researcher changes on purpose. In this example, the researcher has applied a fertilizer called fertilizer X, and they're applying this fertilizer to some of the plants, but not all of the plants. The dependent variables that they're measuring at the end are things like how much did the plant grow? How many leaves did the plant have? Or the number of fruit compared to the plant that was not fertilized with fertilizer X compared to the plant that was fertilized with fertilizer X. So the independent variable, the thing we changed on purpose, was the fertilizer. The dependent variable were things like how tall did our plant grow? how many leaves did it have, and how much fruit did it produce. Over here on this side where this child is sleeping, I would like to look at the independent versus dependent variable. In this experiment, they wanted to know, are test scores impacted by the amount of time spent sleeping the night before a test? Well, what is the thing that we are changing on purpose? That is our sleep. So our amount of sleep is our independent variable. Our dependent variable is the grade that students then earned on that test. Remember, down here it's telling us that the independent variable influences or impacts the dependent variable. Last but not least, I would like to look at this graph in the bottom right-hand corner. And the title of this is Kansas implemented a mask mandate on July 3rd. Some counties opted out. So this shows us the relationship between counties that had a mask mandate and that who did not. So the independent variable, go ahead and think for a second before I tell you, what do you think the independent variable in this experiment might be? Hopefully you said the independent variable was wearing masks. Perfect. Now, if it's wearing masks is the independent variable, what is the thing that the researchers are measuring? What is our dependent variable in this experiment? Hopefully you said number of cases. So the number of cases of COVID is the dependent variable in this experiment. So guys, it's really important to know that the independent variable always goes on the x-axis. The independent variable always goes on the x-axis. The dependent variable always goes on the y-axis. So look, the independent variable was the number of cars washed, and the thing that depended on that, or the dependent variable, was the amount of money raised, because the amount of money raised depends on the number of cars that the individuals washed. So I want to show you guys this graph again to emphasize some really important points. First, please remember that the x-axis always is the independent variable, and the y-axis is always the dependent variable. Now, I know that this might be a little bit hard to remember, so I'd like to teach you a quick trick. I remember dry, mix, and you might be thinking, that's weird. Well, I remember that D is the dependent variable, that R, if you remember in math, is the range, and Y is that variable I'm looking at, the y-axis. So dry and then mix. And the M over here, unfortunately, doesn't really stand for anything, but that I is independent, and that X stands for the x-axis. So hopefully this helps you remember that the dependent variable is always on the y-axis, and the independent variable is always on the x-axis. So let's go ahead and look at this graph and see if we can determine the independent and dependent variables. Well, remember that the dependent variable should really always go on the y-axis, and the independent variable should always go on the x-axis. But let's make sure that this makes sense. This says time since first case, and this says number of cases. Well, we know that the time since the first case should be the independent variable, and the number of cases is the dependent variable. Let's look at another example. So here's another example. We need to determine the independent and dependent variables here. So first, I want to look at the x-axis. The x-axis has different drinks or different items that contain caffeine. So we know that this x-axis is the independent variable. And on the y-axis, it tells us how many milligrams of caffeine are in each of those products. So I'm going to write dependent here. Perfect. So now that we've talked about independent versus dependent variables, we need to talk about graph scales. Scales are very important because they help us to understand what data means. It also helps us to avoid confusion about how much of something there might be. So let's talk about this a little bit more. Here in this example, it's really important to notice that the scale on this x-axis is in months. So the scale on the x-axis is in months. And on the y-axis, we see that this is percentage. And we notice that the difference between each of these percentage points is 2.5%. Wonderful. There is one thing I want to draw your attention to on this graph. We learned that graphs should always start at 0. Can you look at this graph? Does this graph follow those rules? Hopefully you said no. This graph starts at 32.5%. So to be a better and more accurate graph, this graph should really start at 0%. Let's look at another example. Here on the x-axis, which remember is the independent variable, we have movies as our category. And on the y-axis, or on the dependent variable side, we have number of people. And we notice that every one of these lines is one person. Notice that the scale doesn't change. Every time we move up a line, we go up by one individual. So we also need to make sure we understand graph sources. Graph sources tell us where the information is coming from. And it's really important as viewers of information and data that we understand and know where the information we're looking at comes from, so we can make sure that the source is a reliable one. All good graphs should always share the source of their data. If a graph does not readily share the source of their data, it might not be a good graph to look at because they're not willing to share how they got their information. So let's look at this graph again. How can we tell the source of this graph? Well, my goodness, how convenient. It says right here, source. That tells us where this data and where this information comes from. And this says this comes from NPR, which if you don't know is National Public Radio here in the United States. It comes from the Robert Wood Johnson Foundation and the Harvard School of Public Health. So we would think this is a very reliable source, right? It is coming from NPR News, which is a reliable news source, and from Harvard School of Public Health, which is a research institution. Let's look at this data and see where the source is from. Instead of saying source here, it says data from. That's another way that we can identify our source. And this says the data is from the Mayo Clinic. And the Mayo Clinic is a research institution that deals with medical needs here in the United States. It's a medical center that deals with academic research. And so this is also a very reliable source. So now we need to practice. Remember, we ask ourselves the following questions. What is the topic of this graph? What is the graph comparing? What is the independent variable? What is the dependent variable? What is the scale of the graph? And what is the source of the data? So let's look at some examples together and ask ourselves these questions. So here is a graph. Remember, the first question I ask myself is, what is the topic of this graph? So I'm going to look at the X and Y axis, and I'm going to look at the title so that I can determine the topic of this graph. Well, this says the title is Daily New Confirmed COVID Cases per Million People. And I can see that on the X-axis, I have time, and on the Y-axis, I have nothing listed, which may seem like a problem, but luckily it's not, because the title helps us figure out what would go on that axis. Here it says the number of cases per million people. So I can go ahead and label my Y-axis cases per million people. So I know the topic of this graph is the number of cases per millions of people in the world of COVID-19. The graph is comparing time on the X-axis to the cases per million people on the Y-axis. The independent variable on the X-axis is time. So I know that that's my independent variable. And the cases per million people, that is my dependent variable. Perfect. What's the scale of the graph? Well, On the y-axis, our scale is 10 people. And on the y-axis, on our y-axis, our scale is 10 people. On the x-axis, our scale is time. And lastly, but not least, it asks us to find the source of this data. And here we see that the source of this data is the European CDC. And that means the European Center for Disease Control, a very reliable source when we're looking for information about COVID data. Let's do another example together. First, we're going to ask ourselves, what is the topic of this graph? Well, let's look at the title first. The title of this graph is Cable Pain equals Netflix Gain. Every year it says the 18 to 24 subgroup has watched fewer hours of traditional television. It's no coincidence that this is corresponded with record high share prices for Netflix. So let's look at this graph. This graph is comparing time. So I see time on my x-axis. And I actually see two y-axes here. On this left-hand side, it says hours of week of TV per age group for 18 to 24. And on this side, it says Netflix stock prices. So first we need to look to see that this key tells us that this blue line shows us the hours of TV per week. So I can see the hours of TV per week decreasing. This red line is my Netflix stock, and you can see our Netflix increasing over time. So what's the topic of this graph? The topic of this graph is looking at or comparing the amount of cable TV versus Netflix that people who are 18 to 24 watch, and looking at the amount of stock or the stock price for Netflix. And the graph is comparing two sets of things. It's comparing time and hours of TV per week and time and Netflix stock price. Wonderful. Now we need to look at the independent and dependent variables. Well, both of these sets of data have the exact same independent variable, and that independent variable is time. And hours of TV per week, this is a dependent variable. And the Netflix stock price is also a dependent variable. So here in this example, we actually have two dependent variables. What is the scale of our graph? Well, down here in the time section, we can see that the scale of our graph is 1 year. In the left-hand side of hours of TV per week, we can see that every single section is 10 hours. And on the right-hand side for our Netflix stock, we can see that every single thing is $50. Wonderful. Now we need to look for the source of our data, and luckily it is right here. The source is Nielsen, Toluna, and Yahoo Finance. Wonderful. Hopefully in this video, you were able to better understand how to read graphs and how to understand basic graph skills.